Okay, your author actually brings up the concept or the topic of differential equations, and believe it or not, this is actually an entire class. We're actually going to now have it here at Flagler as part of our new major. But it's very common in Calc 1 to at least bring up a very simple differential equation and talk about, all we're talking about is really finding an antiderivative. So a differential equation is simply an equation with a derivative in it. So let's say we have dy dx equals something, some function of x. And what we want to find is y. So in other words, we want to find the antiderivative of the derivative to figure out what y is. And usually we're also given another piece of information called the initial condition. We know y at some value of x, call that x naught, is equal to y naught. That's like that example before where we said, f of capital F of 1 equals minus 1. Well, it's the same idea here. Y at some value of x equals some value of y, some y. Okay, so for example, let's say we have the following initial value problem, and I'm using velocity and stuff, but it's, this could be dy dx, but we have dv dt. So we want to find v of t. So we know the derivative of v is 2 minus 6t. So how do I find v? Well, I find the antiderivative of 2 minus 6t. So what function, if I take it, gives me 2? Well, that's 2t. And then what function gives me t? Well, that's t squared over 2, so that simplifies to minus 3t squared. And then don't forget to add your plus c. And then you have this additional piece of information, the initial condition, v of 0, v at t equals 0 is equal to 4. So v of 0 equals, well, when I plug in t equals 0, I get 0 minus 0, so it's 0, plus c. But that equals 4, so that tells us that c has to equal 4. So v of t is 2t minus 3t squared plus 4.